Hello friends, I'm very delightful to introduce you to a new course called Microcontroller and Application. This course is basically for TY Diploma students and in the electronic group. Now this course is really very important from application point of view, and hence I have today I'm going to take a topic called Microcontrollers and Applications. Now, basically this subject in all deals with various applications in various domains, like in medical domain, in house appliances, in automation industry, in automobiles, in your mobile phones and various other applications. So this is basically a very crude or very heart of all the systems. Let us understand a very brief introduction first to what actually this course is all about. Then we will understand how the basic development of this course will happen. So basically, before going to microcontrollers, we should first understand what is microcomputers. So here I have drawn a microcomputer diagram in which I have given you a basic overview of how the elements of microcomputer or what are the basic building blocks of a microcomputer. Now basically when I call computers, it means to compute. So this is a device which computes. So for computing we require a processing unit. So we have a central processing unit. Then we have to store our data for future use or to use it later on, we have memory, which is further divided into two subparts, which is a RAM memory and a ROM memory. Now what do you mean by RAM and what do you mean by ROM is, RAM stands for random access memory and ROM stands for read-only memory. And then we have input-output devices. Now basically if we look at this, it becomes very simple and it looks very simple system. But you just analogize this whole stuff with the human body. In the human body we have brain, which has two units. One is the processing unit and second one is the memory. So we have the processing unit and the memory. So the memory is used to store the information that has been given to us so that it helps in sometimes to access or to process, and sometimes it is helping us to give some information. So there are two types of memories. One type of memory which we need to pertain forever. For example, when you were kids, you have been taught like A for apple. When you have been taught for A for apple, now whenever you see apple, you always correlate it with A. This is a permanent data storage in your memory. Like everyone gives you an information like he is your uncle, she is your aunt, she is your mother, he is your father. So this data is fed permanently in your memory. It is not going to get erased. It will pertain with you forever. This sort of information is stored in ROM, which we need to pertain forever. So we can only retrieve it. Once we write it, we don't want to erase it again. So we called it only read-only memory because we need to read from that memory. What about RAM then? RAM is a memory in which we just need to get some information at some point in time. Like for example, I am walking through a street and I am supposed to see a person. I have seen that person, I have registered it in my brain. His shirt was very beautiful or very nice. I have seen it. I have registered in my brain. But as I walk through for some distance, I will forget what I have seen. So in that type of memory, wherein we don't store the data permanently, we call it as a RAM memory. So for the memory purpose, we have two purposes of memory. One is the RAM, wherein we store some data for some time and then we erase it. And then we have some other memory which stores the data permanently. So we have RAM and we have ROM. Then we have input-output devices. Now, what are input-output devices can be compared to with our human body? is our eyes, our nose, our ears, our tongue and hands and legs and all these parts of our body are nothing but input-output devices. They provide the information to your brain for processing. So all the external affair communication takes place with I/O devices. So if I wanted to communicate with my CPU or my brain, I need to communicate with these peripherals or I/O input-output devices. When I listen something to a music, and if it is very nice, I feel cool. That is how I hear. That means I take the input from my ears, that are my input devices, and I process in my brain, and then it relaxes. That means that device is processing, the CPU processes it, and then it gives you a feeling of relaxation. This whole analogy can be brought with respect to a human body. And this is how it works. Now, you have two hands, two eyes, two ears, and if I suppose give you, if I pinch on one of your hand, of course, the brain should understand that yes, this was this hand which gets pinched, not any other thing. So if you have many I/O devices and many memory locations, then you require a particular address, like you have roll number in your class because there are many students. So to address a particular I/O, we have addresses. Now, CPU generates this address to call onto a specific or to address a unique I/O or a unique memory. Similarly, if I wanted to pass some data to the CPU, I require the data lines. So there are two basic types of lines that we have in a processor. One we called as address lines. The second we called it as data lines. From the address lines, we transfer address. From the data lines, we transfer data. We have third type of lines which I have not mentioned over here are the control lines. They are your nerve system. As your nerve holds all the body parts, in the same way the control signals are transferred to the nerve of the CPU or the microcomputer. Now this diagram is also called as the architecture or a very top view of a microcomputer. Now there are basically two types of architectures. One is called as a von Neumann architecture and second one is called as the Harvard architecture. Now what is the basic difference between a von Neumann architecture and a Harvard architecture is, in von Neumann architecture, the instructions and the data are stored in one memory. Whereas in Harvard architecture, the instructions and the data is stored in two different memories. That is, we have separate data memory and separate instruction memory. 8051 partly belongs to this architecture because it has a separate ROM and a separate RAM. So now we have understood what are basic elements of microcomputer is. Now, I will come to microcontrollers. How to relate this topic, microcomputers, to microcontrollers. Now, microcontroller has CPU, which we call as core, the memory, both RAM and ROM, the I/O devices, and the timers all together in one package. So we have all together a CPU, memory, RAM and ROM both, I/O ports, that is input and output devices, timers, all to be together packaged onto one chip. Previously, in the year 1971, when it was being first introduced, it was called as a system on chip. Today, the definition of system on chip has been changed. But this is a perfect example of system on chip. I hope you have understood that what do you mean by microcontrollers. Many beautiful examples of microcontrollers are available to us, like washing machine, microwave oven, your car keys, and your mobile phone is a best example of microcontroller application. So this is how microcontroller is so important in our life. It drives our life, I would say. And in Vidyalankar, we excitedly study this and we explain this with all real life examples. For more details and information, you do visit our nearest centers. Thank you.